Hi, I'm Cheryl Leach. In this problem, we're asked to approximate the zeros of the function f of x equals x squared minus 5. And we're in particular looking for the one that's near x equals 2. And we're supposed to do this using Newton's method. And the problem also requires that we only do 2 iterations of Newton's method. Well, Newton's method is a numerical technique. And oftentimes it involves a lot of numerical calculations, a lot of number crunching. And for this reason, we often use tables to help us out. But in this particular problem, since we only need to do 2 iterations, instead of concentrating on the calculations, I'm going to explain a little bit about Newton's method and what it is and where it comes from. So we know that the formula for Newton's method is x of n plus 1 equals x of n minus f of x sub n divided by the derivative at x sub n. Okay, well, exactly how do we do this? Or where did this formula come from? Well, in Newton's method, we always start with a guess. We're guessing where that x-intercept is going to be. And that guess is going to correspond to that x sub n value. Then we need to find the point on the curve that corresponds to that input. That's where the f of x sub n comes in. The next thing that happens is we want to find the tangent line to the curve at that point. Well, we know when we're looking for the equation of a tangent line that we need one point, which we already have, and the slope of the tangent line. Well, the slope of the tangent line is the derivative. That's where this piece comes in. After that, we need to find the x-intercept of that tangent line. That's where this entire piece comes in. And finally, the answer will give us the x-intercept, and it will be our new guess. So that's going to be the new guess. Well, this seems a little complicated, so let's look at it from a graphical perspective. Okay, what are we doing? We're starting with a guess. Let's say that's our guess. We're going to find the point on the curve. It's going to be located right here at my guess. Then I'm going to look for a tangent line to the curve at that point. So the tangent line is going to look like that. Then we're going to find the x-intercept of that tangent line, which occurs right here. That's going to be my new guess. And then I start the process all over again. Okay, so let's go ahead and take a look at our particular problem. And we may go back to our explanation, the first iteration, to see how it's fitting in. Well, I already have my function, and I have my guess. So the other piece that I'm going to need to set up my formula is the derivative. So let's go ahead and find the derivative. F prime of x is going to equal 2x. So now I can set up my formula for Newton's method. It's going to be x of n plus 1 equals x of n minus the function, which will be x of n squared minus 5, all over the derivative, which will be 2 x sub n. All right, so in this particular case, I know my initial guess, x sub 1, is going to equal 2. So I would like to calculate the next guess. So I'm looking for that point. So I'm going to plug it into my formula. I'm going to have 2 minus 2 squared minus 5 all over 2 times 2. So I'm going to have 2 minus, and this will be a negative 1 over 4. So I have a result of 2.25. That's my new guess. Well, let's back up a minute and take a look at how that fit into my process. I started out with my guess. My guess was going to be 2. Then I needed to find a point on the curve at my guess. So if I plug 2 into my function, I'm going to have 4 minus 5, which is a negative 1. Then I need to find the tangent line to the curve at that point. So what do I know? I know that the point 2, negative 1 is on my curve, and I know the slope of a tangent line at that point. Well, here's my slope, because that's the derivative, is going to be 2 times 2. So 2 times 2, which is 4. So the equation of my line is going to be y minus a negative 1 equals 4 times the quantity x minus 2. So I've got y plus 1 equals 4x minus 8, and y equals 4x minus 9. Okay, so that's the equation of my tangent line. Now I need to find the x-intercept. We find x-intercepts by setting y equal to 0. So if I do that, I'm going to have 0 equals 4x minus 9, which means that x is going to be 9/4. Well, guess what 9/4 is? It's 2.25. So my process worked exactly the way it was supposed to. All right, the problem said 2 iterations. I've only done 1. Let's go ahead and get that second iteration. So for x sub 3, I'm going to use 2.25 as my new guess. So I'm going to have 2.25 minus 2.25 squared minus 5 all over 2 times 2.25. Now this one's going to require a little more number crunching, so I'm going to go ahead and pull out my calculator. And so I'm going to have 2.25 minus, then I'll subtract that fraction. 2.25 squared minus 5, all divided by 2 times 2.25. And when I hit enter, I end up with approximately, because this will be a decimal approximation, 2.236. And actually, as I'm looking at it, it's a repeating 1. So let's approximate this as 2.24. Okay. Now, I'm not going to go through and look at the analysis again because these numbers are quite a bit more complicated. But if you were to spend the time to do so, you would find out that our third guess, or x sub 3, matches the x-intercept of my new guess. I hope that was helpful. Thanks.